Hello, today we are going to stay in section 4.2, do a little bit more with angles. There is something called the angle addition postulate. I like to abbreviate it AAP, just in case I throw that out there in the future. AAP is angle addition postulate. What it does, it says when you add the measures of two smaller angles, you get the measure of the larger angle. Okay. So two parts kind of make a whole is kind of the idea. Now, just because again, I'm a visual learner, if I was looking at a picture, I'm going to add a couple points on here. I'm going to go A, B in the vertex, C along the bottom, D in the middle. Okay. So what the angle addition postulate says is that angle ABD, which is this kind of half angle on the top, plus angle DBC, which is the angle on the bottom. If you add them together, you equal angle ABC, which is the entire big angle. So the idea here is that a small angle plus a small angle equals the larger angle. Okay. Now, the reason that we have the angle addition postulate is this allows us to add any two angles together. The bisector yesterday, the bisector gave you two equally sized halves or two equal angles. Today, you could have, one that's a different size than the other, but you can always add them together. Okay, so little different bisector, you always have equal parts, but on an angle bisector, you could do a small plus a medium equals a large. Two parts always equal the larger angle that it forms, though. So if we look at this very first example, okay, we want to find the measure of KLM, so this whole entire big angle. If we know that KLB, this one on the bottom, is 26 degrees, I'm going to put 26 in there, and we know that BLM, this top angle, is 60. Okay. Well, to find the measure, we know that the two parts should make a whole. So if I wrote it out in terms of the angle addition postulate, then angle KLB plus angle BLM should equal angle KLM, the big angle. We know that KLB is 26. We know BLM is 60. And if you add those together, 86 degrees is angle KLM. So we're just kind of following the two parts add up to the whole big angle. On the right here, if the measure of IJA is what we're going to try to find. IJA is kind of this angle on the right. If AJK is 61 degrees, and we know that IJK, which is the whole big angle here, is 153. Again, if you think of the angle addition postulate, the two parts, IJA plus angle AJK should equal the whole big guy, IJK. I don't know IJA at the moment, but AJK is 61 degrees, and IJK, the whole big guy, is 153 degrees. So if I subtract 61, 153 minus 61 is 92 degrees, is my missing angle measure. What if we know angle A and angle B are complementary, okay, which remember means that they add up to 90 degrees. Measure A is 3x plus 7. Measure B is 6x plus 11. Determine the measure of each angle. Okay. Again, if we know that A and B are complementary, then angle A plus angle B should equal 90 degrees. Okay. We know angle A is 3x plus 7 plus angle B is 6x plus 11 should equal 90 degrees. Okay. Now, I'm going to combine like terms. 3x and 6x make 9x. 7 and 11 make 18, still equal to 90. If I subtract 18, now I have 9x equal to 72. And if I divide by 9, x equals 8. Okay. Now that's x. That's not the final answer, though. They want the measure of each angle. So if I'm talking about angle A, again, A is 3 times x, which we know is 8, plus 7. Well, 3 times 8 is 24, plus 7 is 31 degrees. And angle B, which is 6 times x, or 8, plus 11. 6 times 8 is 48, plus 11 is 59 degrees. And if you double check over here, 31 and 59 do add up to 90 degrees, so they are definitely complementary. Okay. What about down here? If we know that P is in the interior of XYZ, we know the measure of XYP is 25 and the measure of PYZ is 50, we need to find XYZ. Okay. Now, I'm going to draw a picture for this one. P is in the interior of angle X, Y, Z. Okay. And if P is on the interior, he's kind of splitting us in half. Okay. We know XYP in my picture is the top one, is 25. And PYZ is the bottom, is 50 degrees. Okay. So angle XYP plus angle PYZ, the two halves, should equal angle XYZ. Again, we know these measures are 25 and 50. 25 plus 50 makes 75. If M is in the interior of RTD, okay? Don't always have to draw a picture to the right. Maybe I do an angle to the left. Okay. So we've got RTD. We know that M is in the interior. You don't always have to split it perfectly in half either. We know that RTM is 40 degrees. And RTD, which is the whole big angle here, is 65 degrees. According to the angle addition postulate, my two little guys, angle RTM plus angle MTD equals the big angle RTD. RTM plus MTD equals RTD, the whole big guy. We know that's 65. Nope, that's not right. I gotta find some white out. Oh, the dangers of pen. All right, we fixed that little guy in there. We know he is 40. There we go. This guy over here is 65. And we're solving for MTD. Well, all I'd have to do is subtract. 65 minus 40 is 25 degrees. There we go. All right. H is in the interior of EFG. So if you want to make a picture, go ahead. Okay, we've got E, F, G. H is in the interior. We know that EFH top half is 75. We know that HFG is 10x. And we know that EFG, the whole big guy, is 20x minus 5. Okay. Now, if we think this one through, again, little halves first. Angle EFH top half, plus angle HFG, bottom half, should equal the big angle EFG. We know EFH is 75, HFG is 10x, and EFG is 20x minus 5. So we're just kind of placing that in that angle addition postulate. Then we need to solve. So I'm going to subtract 10x to the right, which that should give me 10x. I'm going to add 5 to the left. 75 plus 5 is 80. When I divide by 10, x equals 8. Okay, so that should go on that line right there. The other measure that they want us to find is HFG. So remember, the measure of angle HFG was that 10x. Well, we know that x is 8, so we're looking at 80 degrees. Now, this last one at the bottom, we've got a little bit of a more complicated picture. We know that lines DB and lines EC, that they intersect at point F. If the measure of angle BFC is 44, I'm going to put my 44 in there, and angle AFB is 61 degrees, put my 61 in there, then let's start by finding the measure of angle AFC. AFC, well, it looks like I would just have to add those two angles together. So for measure AFC, I'm just going to take my 44 plus that 61. If you add that together, you get 105 degrees. Next, we want AFE. AFE is this angle right here. Well, if you kind of look side by side, these three angles all add up and make a straight line. So I could do, for angle AFE, I'm going to work backwards. 180 minus that 61 minus that 44, that's going to leave me with 75 degrees for AFE. Again, all three parts make 180, so I'm just working backwards. And then for EFD, again, I can do kind of that same approach. EFD and that angle, all three make 180. So 180 minus the 75 minus the 61 puts me back at 44 degrees. So you're just kind of playing and adding angles together today. So two angles add up to the bigger one. Again, if it helps to kind of write out the equation first, like this angle plus that angle equals this bigger angle, then plug in your parts, that is a good strategy. Okay. So give that AAP, or angle addition postulate, a try for tonight.